We're here at Kromek today showing off some of the AARM radiation mapping technology, which is the technology which uses Kromek sensors of different types to be able to survey sites and environmental areas, either using drones or using robots which are on the ground. And today we've brought along the robot dog, Sparky as we call it, to demonstrate that we can map an area autonomously using a robot instead of a human. So the drone system is a capability that you can use for emergency response, and indeed that's why we developed the technology. It was following Fukushima, and it provides a capability which allows you to get real-time situational awareness of the spread of radiation or the distribution, but without putting a human being into the danger zone. So robots which can fly are obviously terrain independent. They're very quick to get to the location which you need to survey, and they can transmit data wirelessly and also via the 4G cellular network. So people who could be literally hundreds or even thousands of miles away can see the data as it's being recorded in real time.
So we use drones for both civil nuclear and security applications. So in the civil nuclear area, it means you can put drones into an area where you don't want people to go. So you can put your detectors on there without putting anybody in harm. And when you go into some quite high areas for mapping, you can understand what's in those areas, which you wouldn't be able to do previously without drones. Within the security markets, people also want to be able to send drones into hostile environments, which means you don't have to send the people in with them. So you get a lot of information remotely without putting people in danger.
Whether it's a nuclear site that needs to do routine perimeter surveillance to make sure that there's no unexpected radiation escaping from their facility, or it's maybe a site that's actually in active decommissioning where we expect radiation distributions to change. Using a UAV technology allows you to make a very rapid assessment of that radiation field, whether it's changed or not. And you can use that same technology in environmental surveying and even for things like mineral ore prospecting for valuable metals like gold, for example, or copper, and we can localize where there are interest areas. We would call them hotspots, but generally they're areas of locally elevated radiation. And so to within a meter or so, we can identify where they would be, and that would allow then you to go in on the ground and make samples, for example.